Hi, this is Allison for Gene Codes Corporation to give a demonstration on the new release of Sequencher, Sequencher 5.1. Sequencher 5.1 enhances the sequencing experience by giving you more options and better tools than before. Its easy-to-use interface allows users to get more information out of their data. In this version of Sequencher, we have added two new third-party tools, Muscle and Velvet, along with Multiplex ID, assembly modes, and an defined amino acids command. In this tutorial, I will go over these additions that make Sequencher 5.1 a powerful, useful tool in sequence assembly. First, I will show you the use of muscle and the finding amino acids command using Sanger sequencing. We start by cleaning the data using the trim ends command in the sequence window. If you're familiar with Sequencher, you know that trimming can increase the quality of our data by removing the low-quality ends. We'll check to make sure our ends trimming criteria is correct, and then we'll click on that Trimmed Checked Items button. And this will trim our sequences. Once our trimming is complete, we can see that the quality of our basis has gone up. We're now going to align our data using Muscle, located in the Assembly menu. Muscle is a fast and accurate alignment program used for multiple sequence assembly without the use of a reference sequence, also known as de novo assembly. We can view our contig in the basis window and through the use of chromatograms. Chromatograms allow us to analyze the raw data and look at the quality of each base and make edits. We're going to use the Find Amino Acids command to identify individual or sequences of amino acids within our sequence. We're going to use the Find Next button to locate the next amino acid that we would like to find. You can do this throughout the entire sequence. We're going to compare our bases to the consensus in the sequence window. And this will create a variance table for us that shows the variations between the sequences within our contig. And we're going to create a report to give us the information we need, all in one easy-to-read document. Now I will show you the newly added next-gen tool for de novo assembly in Sequencher 5.1. Velvet, located in the Assemble menu, is Sequencher's third-party tool that specializes in de novo assemblies. Velvet can assemble FASTA or FASTQ data that is either single-ended or pair-ended in reads. If your pair-ended read files have already been merged, then you can use that merged file by clicking the File 1 is Pair Reads checkbox and loading that file into your Select File 1 button. The hash length is the value or word length that sets the length for the DNA word used in the construction of the Velvet assembly. Once you click Assemble, Velvet will complete the de novo assembly quickly, and you can select a consensus and view your results in Tablet by selecting that through the contig window. Tablet will open and import your reads for you so that you can use Tablet's tools to view your data. Sequencher 5.1 can use a multiplexing method of assembly with paired-ended or single-ended reads in GSnap or Velvet. First, you must change the assembly mode to Multiplex ID. I will use GSnap reference guided alignment in this demonstration. Multiplex ID is quick and easy. Each sequence has a specific barcode associated with it on the 5' end. Paired end data have the same barcode at their 5' ends, labeling them as pairs. A multiplex ID list is required when using a reference-based assembly in GSnap. GSnap reads their barcodes and divides the data into various bins. It then takes the sequences in each bin and assembles them into contigs. An alignment window will appear to show you when a bin has completed its assembly. The window will also show you the name of the bin under the MID name, the number of pairs, and the status of the assembly. You can view a processing report based on the bin alignments when all the bins have completed their assembly. To compare the results of each bin in Sequencher, you can create a variance table. You can do this by selecting all and selecting Compare to Consensus in the config window. You can then create a printable report that contains all the valuable information you need. We can also view our contigs in Tablet by selecting a read and using the tablet selection in the config window. We can use Tablet's tools to analyze and view our results. Once again, Sequencher is new and better than before, with the addition of Velvet, Multiplex ID, and Muscle. When it comes to sequence alignment, Sequencher 5.1 is a powerful and user-friendly tool.